Hello, Namaste students. ಹಿಂದಿನ ವಿಡಿಯೋದಲ್ಲಿ ನಾವು ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಆಫ್ ಅ ರೆಕ್ಟ್ಯಾಂಗ್ಯುಲರ್ ಲ್ಯಾಮಿನಾ ವಿಚ್ ಈಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಸೆಂಟರ್ ನಾವು ನೋಡಿದ್ದೀವಿ. ಸೊ ನಾವು ಈಗ ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ವಿಚ್ ಈಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಒನ್ ಎಂಡ್ ಆಫ್ ದ ರಾಡ್ ಆಫ್ ದ ಒನ್ ಎಂಡ್ ಆಫ್ ದ ಲ್ಯಾಮಿನಾ ಆರ್ ರಾಡ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ. ಓಕೆ, ಸೊ ಲೆಟ್ಸ್ ಡಿಸ್ಕಸ್. ಸೊ ನಾವು ಇಲ್ಲಿ in this diagram I have considered as a lamina. Similarly, the rotational axis I shifted to one end of the lamina, and the element same as usual. Earlier video you saw, that is element I have considered as a small element with a thickness of dx, right? And this distance from the rotational axis to this element, it is given as a x. Okay, so now x, okay. So by definition of moment of inertia, we know that I equal to mr square, right? M is the mass of that element and r is the distance from the element to rotational axis. So mass of that element is, as earlier part video we calculated, that is m by l into x square into dx. So m by l is constant, take it outside. X square is integrating x square, that is x cube by 3 over the limits 0 to l. So in the previous video we have taken l by 2 to minus l by 2 to plus l by 2. Here the limits, it is varies from 0 to l. Why? Because now the rotational axis is shifted to one end of the rod. So total length it is considered from the rotational axis, it starts 0 to l. Okay, so therefore I we will get as ml square by 3. So now again, by the same way we will discuss one more condition. If we shift the moment our rotational axis exactly to the center of the lamina perpendicular to its plane, so then what happens? It's moment of inertia value that we will discuss. So now consider, now we are considering the same as earlier we done as a lamina. Okay, so for this lamina I'll draw an element, and this is passing, I'm showing that the rotational axis passing perpendicular to plane, right? And it is exactly to the center of the lamina, right? Okay, so now that is the breadth of the lamina, that is breadth breadth B, and length L. L is the length of the lamina, right? So now, so here you can observe in this figure, so already previously two things we found, that is moment of inertia which is passing through the one end of the rod we got, and also we found the moment of inertia which is passing about its breadth direction, means along the center of the, passing through the center of the, not along the side, one side of the lamina, right? So now if I draw a 3 axis, x, y, z axis, so here the two axes are passing how? These two axes are passing, one it is axis passing through the parallel to the breadth, one is the axis passing through the parallel to the length. One more third axis where it is, which is passing through the perpendicular to lamina, right? So that therefore I can use here as a perpendicular axis theorem. So that by the principle of perpendicular axis theorem, we can say that any one axis, the moment of inertia of a axis which is perpendicular passing through the lamina, that is equals to passing through its center, is equal to and perpendicular to plane, perpendicular to its plane is equal to, so another two axes we have, one is which is parallel to what, length, one is parallel to breadth. So therefore I can write it what, moment of inertia of the axis along x and y. So therefore I can write it as moment of inertia of a about an axis parallel to its breadth and parallel to its length, right? And moment of inertia about an axis parallel to its length, right? So therefore I is equals to, I can write it Iy equal to Ix plus Iz. So Iy is what, which is passing through center perpendicular to plane. Ix is what, moment of inertia which is parallel to breadth, parallel to length and parallel to breadth. So therefore mb square by 12 plus ml square by 12, we will get I is equals to ml square plus b square divided by 12. Thank you friends. So if you want to more information about B.Sc related concepts, please subscribe and follow my channel. Thank you students.